Gauss's law. We have studied about the flux linked with a surface which is kept in an electric field. We have also studied the flux linked with a closed surface kept in an electric field. Closed surface, the surface which is closed from all the sides. If we light up a bulb inside, the light should not come out. Then that surface is a closed surface. It may be of any shape. It may be a cubical, it may be a spherical shape, it may be a cylindrical shape or any shape. Okay? Now, Gauss theorem tells us about if there is a particle having charge q and it is enclosed by a surface. Now we know that every particle which is having charge will make an electric field around it in the space. This is also making electric field. And how do we represent electric field? With electric field lines. So let us say it is making electric field in all the directions. This we are representing, and like a football, like a bulb slide, in every direction. Now we enclose it with a surface. This surface may be of any shape. Okay? And we have covered it from all the sides. Now, these electric field lines, we say the electric field lines are linked with the surface. What is the word we are using? Link. The quantity of electric field lines which is linked with the surface is known as electric flux. So, this we have studied in the previous lecture, the concept of electric flux. So, the electric flux here, how do we calculate it? This also we have studied, that this total electric flux with the closed surface is closed integral E ds. What is E? Strength of electric field at any location. ds, this small area is ds, which has a vector, unit vector. This is electric field vector. So, electric field vector, area vector, this is angle theta between them, and this closed integral EDS, which has a magnitude of E ds cos theta. Okay, we make EDS calculation at this place, then we make EDS calculation at this place, at this place, at this place, at this place, and all these calculation of EDS we join together, we add them up, we call it integrate. So, when we integrate this quantity, this gives us the total flux. EDS gives the flux at this location, this location, this location, and sum of all, that is closed integral, gives the flux linked with the total surface area, which is a closed surface area. Now Gauss says this flux quantity depends upon the charge which is kept inside the surface. Inside, that is very important. Q is charge inside. If this charge is here, Q, then Gauss says it will not affect the quantity of flux related with this. It is effect of only this Q, which is inside, that will be effective. And this total flux linked with the closed surface is 1 upon epsilon naught times the charge. More is the charge, more is the flux. And what is the constant between them? 1 upon epsilon naught, or this we can write phi electrical, that is flux electrical, is this closed integral E dot ds. This is equal to q upon epsilon naught. This is Gauss theorem. Flux is q upon epsilon naught, and this q upon epsilon naught. Now we can write it in the words. The Gauss theorem says that according to Gauss theorem, the electric flux linked with a closed surface is 1 upon epsilon naught times the charge enclosed by the surface. And there are two equations we use for this. One is phi is equal to q upon epsilon naught, and the detailed is this one. So remember, this is Gauss theorem. Okay. Now, there are so many clarifications and doubts about it. We will take them one by one. The first one is that the Gauss theorem is true for closed surfaces. True for closed surfaces only. Yes, if the surface is open, some of the flux will go out, will not be linked with the surface, and our calculation will go erroneous. Usme error aa jayegi, so it has to be a closed surface. Okay, the second thing is, if this charge is 1, if the charge is 1 or the charges are many, it hardly matters. If this q charge is here, 1 q charge is here, 1 q charge is here, then in place of q, how much we will take? 3q. All the charges inside. So when we say the charges enclosed by the surface, this may be a single charge, this may be multiple charges, this may be sum of charges. Like if there are plus 3q charge here, there is minus 2q charge here, then the net charge is plus q, we will take plus q charge. Right? So, the second point is, all the charges inside, all the charges inside considered. Okay, then the third point is, if there are some charges outside and there are certain charges inside, then the charges which are outside, will they affect or will they not affect? This is 2q charge here, and this is 3q, this is 4q. Now the flux linked with this surface, this is a closed surface, any shape. This will make an electric field. This will also make an electric field, and electric field lines, this. All these lines are touching this surface. Here, these lines are touching this surface. Will it not change the flux? Will it not affect the flux linked with this closed surface? The answer is no, it will not. Okay, how it is possible when you see that the lines are touching? So I tell you, if these plus lines are entering, see this line, it goes like this. Here it enters the surface and here it leaves the surface. If I take this plus 1, here I take it minus 1, the net is 0. How many lines? this. So this one line enters and this lines leave here. Leaves here, enters here. How many lines are net affected? 0. Because incoming lines, outgoing lines, they become equal. Similarly, this line is coming from here. If I extend this line, this will be like this. Here this line enters and here this line leaves. The net line count is 0. But if there is a charge inside, see this charge. From positive charge, the lines only start. They do not terminate over there. Plus, the line will start from here, going out. The line will start from here, going out, going out, going out. Positive, 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 positive. The flux is +4. There is no minus to cancel out if the charge is inside. Once again, if the charge is outside, see it here. If the charge here is outside, then once again I tell you yes. Okay, see it again. If here is the charge, then it will make a line like this. Here the line enters the surface, here the line leaves the surface, and how much is the net line attached with the surface? 0. Here it starts from here, +1, this, but there is no portion at this. Here this also comes out, here also out. All are going out, but here this is in, this is out. Therefore, any charge which is placed outside the surface has no net effect on the total flux of the closed surface. Right? Okay, so this was the point 3. That is charges outside. Make the flux, no doubt, make the flux, but net flux is only due to charges inside. Okay, then the fourth property, this is we can always use it. Use the Gauss theorem with symmetry. Use the Gauss theorem with symmetrical surfaces to calculate E at a point. This we will show you how we are using Gauss theorem using symmetrical surfaces. In the next topic it will come. Then we should avoid making Gaussian surface or the surface, this closed surface, passing through a charge. Okay. The Gauss theorem depends upon inverse square law. If Coulomb's law or the electric field is not an inverse square law, then the Gauss theorem will not be of this particular shape, of this particular quantity. then it would have been something different. So this particular shape, this particular formula for the Gauss theorem is based on the fact that Coulomb's law is a inverse square law, that electric field is a inverse square law. We will see the proof now, the proof of Gauss theorem, which will show you how necessary it is that this formula comes only when we are using inverse square law. Okay, so these are certain important points of the Gauss theorem, and now we will study a small proof of Gauss theorem, how it was made. There is proof. Proof of Gauss theorem. There is a charge Q located at a point and it is having its field all around it. We will make a Gaussian surface about it. What is a Gaussian surface? Gaussian surface is an imaginary surface, and we can make it anywhere. Gaussian surface is an imaginary surface. We can make it anywhere, and the property which is important for this is that this is a homogeneous surface and this is symmetrical surface. Symmetric. The important point is symmetry. So this is symmetrical surface. Okay. Now, why we want this surface to be symmetrical? We will come to that. Now, for the proof of Gaussian surface, Gaussian theorem, here is a charge Q. Let us consider an imaginary surface in the shape of a sphere. In the shape of a sphere. Such that Q lies at its center. Let its radius be R. Okay, so here we imagine one sphere and with the radius R. This is a sphere. We know the total surface area S will be 4 pi R square. Okay. Now, if this distance is R, this distance is also R, this distance is also R. The electric field at this point, E at a point, is E equal to 1 upon 4 pi epsilon naught Q upon R square. This is we have already studied. Now, here, what is the direction of E? The answer is direction of E is radially outward. This. If we take a very small area here, then what is the area vector? Area vector is normal to the surface, so this is area vector. Let's call it A unit vector, area vector. Now, what is the angle between the two? 0. So, small flux linked with small area here, ds is small area, ds is small flux, we will write d phi. This is equal to electric field E dot or E multiplied by area multiplied by cos theta. Here the quantity of E is this 1 upon 4 pi epsilon naught Q upon R square. This is inverse square law. Remember? Okay. This is to be multiplied with ds and cos theta. Here theta is 0. So this we will write as cos 0, which will turn out to be 1. Now this is d phi, the small flux made here. What will be the total flux linked with the complete surface? Flux linked with complete, that is closed surface of sphere. D phi here, d phi here, d phi here, d phi here, add them up. If we add them up, then what is the process of addition? Integration. For the full surface, we will write it closed integration. So, closed integration of 1 upon 4 pi epsilon naught Q upon R square ds. What does it give us? It gives us the total flux. We will write it phi E. So now, integration of ds, area, the total spherical area is, here you see, one is constant, 4 pi constant, epsilon naught constant, Q and R, these are also constant, so everything comes out. Flux is equal to 1 upon 4 pi epsilon naught Q upon R square and closed integral of ds, area. The total area we will integrate and it comes to be 4 pi R square. Now do the cancellations. This is Q upon epsilon naught. So the phi linked with complete surface, closed surface, is equal to Q upon epsilon naught. This is Gauss theorem. This is proof of Gauss theorem. Now, write it down. Okay. After it is done, remember one thing. This 4 pi R square is what? Area. This 1 upon R square is what? 1 upon R square is inverse square law. By chance, mathematically, this R square get cancelled with this. Now suppose electric field do not follow inverse square law and there is a power 3. There is a power 4. Will it cancel? It will not cancel. If it does not cancel, then R will appear here. And the present form of Gauss theorem is changed. So, the present form of Gauss theorem depends upon what? Depends upon inverse square law. Because electric field is following inverse square law, we have the present form of Gauss theorem. this flux in our calculation. What is the flux? Flux is closed integral EDS. So closed integral EDS is equal to Q upon epsilon naught. This is the Gauss theorem. Okay, so now this Gauss theorem we will make certain applications, and one of the applications is, if we know the flux, we can always find out the charge inside the surface. Like in the previous question, we knew how much was the flux. If that is known to us, then flux multiplied by epsilon naught gives the charge enclosed. Another very important thing it tells us that this phi, we know that this phi is E into area or closed integral EDS. If Q is 0, area is not 0, then E has to be 0. So there is a relation between Q and E. If Q is there, E is there. If Q is not there, E is not there. So this gives us the first law of Maxwell's, which we will study after a few months. The first law says that there is a relationship between Q and E. According to Gauss theorem, it says that if there is Q, there is E, and if there is E, there is Q. They cannot exist without each other, and if there is no E, that shows there is no net Q there. Okay, so this is preliminary things about Gauss theorem, and we will go for applications of Gauss theorem one after the other. Now, see here, the electric field components are, ये एक लोकेशन है, इसमें यहाँ पर इलेक्ट्रिक फील्ड है. ओके, let me separate it. There is an electric field spread in this space. Electric field is a vector quantity, और उसको लिखने का तरीका क्या हो सकता है? We can give its component. X direction में इतना, Y में इतना, Z में इतना. They give E in X direction is this much, E in Y direction is 0, E in Z direction is 0. क्या पता लगा हमको? E सिर्फ किस डायरेक्शन में? X. And what is that X direction? This is the X direction. यानी यहाँ पर E कैसा है? Only in the X direction. So this is indicator of E. Yes. Correct? Okay. अब इसमें हमने एक क्यूब को रख दिया. Suppose this is a cube shape. इसको हमने यहाँ पर ऐसा रखा. अब इस क्यूब शेप पर ये इलेक्ट्रिक फील्ड लाइंस ऐसे जा रही हैं. किसी सरफेस को ऐसे हिट करती है और किसी सरफेस के पैरेलल निकल जाती है. ठीक है. We are supposed to find out, calculate flux through the cube. If they have asked flux through the cube, that means they are asking flux through the closed surface, क्योंकि क्यूब पूरा क्या होता है? Closed surface. तो हमको closed surface पर इसका फ्लक्स चाहिए. अब closed surface पर फ्लक्स निकालने के लिए हमारा मेथड क्या है? We will check theta. All the surfaces, do they have same theta? Then we will make it a constant and take it out from the integration. लेकिन हमने ये ऑब्जर्व किया कि सबके साथ थीटा सेम नहीं है. Here theta is different and here theta is different. Here theta may be different. So we have divided into all the plane surfaces. Okay. So we will start making it. Step number 1. We will write it this way. यहीं से मैं solution start कर देता हूँ. Solution. Phi is equal to, this is our formula for the closed surface. Now, this we have divided into this surface 1, surface 2, surface 3. ठीक है? Now, start putting values. Surface 1 किसको लेना है, इसको हम एग्जांपल मान लेते हैं. दिस, लेट अस टेक दिस एज सरफेस 1. तो हमको इसका एरिया वेक्टर बनाना पड़ेगा. Now here comes a new thing. If this is the cube, which will be the direction of area vector? तो एक चीज याद रखिए, एक हमने कन्वेंशन बनाया है, the area vector in a closed surface will always be outward. Will always be outward. तो इस सरफेस के इधर भी नॉर्मल हो सकता है, इधर भी हो सकता है, तो हमने किसको लेना? आउटवर्ड. अंडरस्टैंड? अब बताइए इस पर नॉर्मल किधर लेना है? इस तरफ, राइट? और इसका नॉर्मल इस तरफ. अब मुझे ये बताइए, इफ वी टेक दिस एज सरफेस 1, व्हाट इज द एंगल बिटवीन इलेक्ट्रिक फील्ड एंड एरिया वेक्टर? 180. इलेक्ट्रिक फील्ड इन दिस डायरेक्शन एंड एरिया वेक्टर इन दिस डायरेक्शन. ये 0 है और ये कितना हो गया? 90, और 90 के बाद ये कितना हो गया? 180. So when it is opposite, we will take it as 180, and cos 180 is minus. Understand? Okay. तो यहाँ पर थीटा कितना लिया जाएगा? 180. ठीक. We will start for surface number 1. थोड़ा सा यहाँ पर सरफेस नंबर 1 को देखिए. ये है सरफेस नंबर 1. इस सरफेस नंबर 1 का एरिया वेक्टर किधर जाएगा? इस तरफ. इलेक्ट्रिक फील्ड किधर है? इस तरफ. तो थीटा कितना? थीटा विल बी 180. ओके, लिख लेंगे इक्वल टू, यहां पर हमको E चाहिए सरफेस 1 के लिए. सरफेस 1 के लिए E कितना होगा? इज एनी वैल्यू गिवन टू अस? क्वेश्चन में देखिए E की वैल्यू है क्या? अच्छा, एक चीज ये बताइए, सरफेस 1 को जो E टच करेगा, कौन सा E लेना है? EX, EY और EZ. आंसर EY and EZ are already 0, so they are not to be taken anywhere. ठीक है? So only EX exists. So EX, this is EX, this is the surface. So how much is the value of EX? This अल्फा इंटू एक्स टू द पावर हाफ. अल्फा की वैल्यू हमको दी है, बट वी विल पुट इट इन द लास्ट व्हेन वी आर डूइंग कैलकुलेशन. सो वी विल राइट इट. ई की जगह क्या लिखना है? अल्फा. एक्स कितना है? ये वाली सरफेस यहां रखी हुई है, ये यहां रखी हुई है ऐसे. ये डिस्टेंस क्या है? x फॉर दिस सरफेस. और ये जब सरफेस कंसीडर करेंगे तो x किसको लेंगे? यहां से लेके यहां तक का डिस्टेंस. इधर कोई सरफेस होती तो x को यहां से यहां तक का सरफेस. अब आप ये देखिए, क्या ये इलेक्ट्रिक फील्ड कांस्टेंट है? नो, इट इज चेंजिंग विद x. इसलिए हम इसकी वैल्यू रखेंगे, राइट? तो इस सरफेस के लिए E की वैल्यू कितनी? तो x की वैल्यू रखेंगे कितनी? बताइए, इस सरफेस के लिए x कितना है? इज इट गिवन? ओके, दिस डिस्टेंस इज इक्वल टू a. एंड हाउ मच इज a इक्वल टू? 0.1. बट हियर वी विल राइट इट a. देखिए, E के बदले में हमने क्या लिखा? अल्फा a to the power half. This expression is for what? E. This expression is for what? This. हमें क्या चाहिए? E. कौन सा E एग्जिस्ट करता है? EX. EX की वैल्यू कितनी है? अल्फा x to the power half. ये बात समझ में आ गई? ये अभी तक हमने क्या लिखा? E. उसके बाद क्या लिखना है? ds. We will write it ds. ds, उसको बाद में इंटीग्रेट करेंगे। ओके, उसके बाद cos θ1 बोलिए, cos θ1 is -1, theta is 180 degree, therefore cos θ1 is -1, डायरेक्ट -1 लिख लेते हैं। Is it clear to you all? Okay, because theta is 180 for this. Otherwise हम इसको पहले स्टेप में 180 लिखते, अगले स्टेप में -1 लिखते। We could have done it this way. ये तीनों चीजें हो गई। Now come to the surface number 2. Surface number 2 आप किसको मानेंगे? ये सरफेस 1 थी, 2 किधर ले, नीचे, ये सामने। अरे आप टाइम वेस्ट मत करो, हैं? सामने, ठीक है। वी विल गो लाइक दिस। दिस इज सरफेस नंबर 2। बताइए इसके साथ थीटा कितना? अभी आपको ट्रेंड किया था मैंने। हाउ मच इज थीटा? यस, तो इस सरफेस के लिए थीटा कितना लेना है? 90, and cos 90 is how much? 0. So I will write it for surface number 2. Okay, for surface number 2 this. For surface number 3, हाँ जी, 3 किसको लेना है? ये यहाँ बताइए। This is E, this is area vector। कितना एंगल है? 0, and cos 0 is 1. Okay, so this will be again surface number 3. अब यहाँ पर ये 0 नहीं हो रहा है because cos 0 is 1, तो हमको E की वैल्यू लिखनी है। बताइए E की वैल्यू इसके लिए कितनी होगी? This is the most important thing in this whole numerical. Value of E for this surface, ये वाली सरफेस, ये जो इधर वाली सरफेस है, दिस सरफेस। ये सरफेस के लिए E की वैल्यू और E का फॉर्मूला क्या है? तो इसके लिए हमने रखा अल्फा। अब बताइए x कितना रखना है? नो, बस यही गड़बड़ है। ये वाला डिस्टेंस a है, पर हम इस सरफेस के लिए कैलकुलेट नहीं कर रहे हैं, इसके लिए कैलकुलेट कर रहे हैं, और इसमें ये वाला डिस्टेंस और आ गया। तो यहां जाते जाते इलेक्ट्रिक फील्ड वीक हो गया या स्ट्रांग हो गया, चेंज हो गया। अब x की वैल्यू कितनी? यहां से चलिए ना, यहां से यहां कितना है? a, और यहां से यहां कितना है? a, तो यहां पर x की वैल्यू कितनी हुई? 2a। तो अब हम जो यहाँ पर E की वैल्यू रखेंगे, उसमें x की वैल्यू को क्या रखना है? 2a टू द पावर, हाँ, ये E की वैल्यू है। समझ आया? दिस इज हाउ वी गेट इट। ओके, दिस इज फॉर सरफेस नंबर 3, ये सरफेस। सरफेस नंबर 4 कितना हो जाएगा? यस, cos 90, तो उसको मैं छोटा सा नोट कर लेता हूं। सरफेस नंबर 4 cos 90। ओके, देयर आर 6 सरफेसेस। थोड़ा इसके लिए बोलिए। सरफेस नंबर 6, दिस इज E, दिस इज एरिया वेक्टर, cos 90। cos 90। So this is equal to, ये चीजें ध्यान रहेंगी। पहली सरफेस लेते हैं तो Ex की वैल्यू में इसको क्या लेना है? A। दूसरी सरफेस लेते हैं तो x को क्या लेना है? 2a, because E is variable। ऐसे बहुत कम केसेस होते हैं, बट वी मस्ट रिमेम्बर कि E कांस्टेंट भी हो सकता है और वेरिएबल भी हो सकता है। E के साथ YZ भी हो सकते हैं, बट इट इज गुड कि यहाँ पर नहीं है. ओके, दिस इज इक्वल टू, अब ये क्या है, cos 90, 0 0 0 0, ये चार तो 0 हो जाएंगे. वी हैव टू कैलकुलेट ओनली 2. ठीक है, इन दोनों को लिखते हैं. इंटीग्रेशन, अल्फा इज ए कांस्टेंट, ए इज ए कांस्टेंट, तो इंटीग्रेशन सिर्फ किसका होगा, ds. ds सरफेस एरिया, सरफेस एरिया का इंटीग्रेशन करिए. दिस इज a, दिस इज a, पूरा एरिया कितना, a इंटू a, a स्क्वायर, हो गया इंटीग्रेशन. तो ds का इंटीग्रेशन कितना हुआ, a स्क्वायर. समझ आया? What is integration? Sum of all ds. ds, 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 sum of all ds is a square. So this now, what we will write it? बोलिए, alpha a to the power half into integration of ds, a to the power 2 cos 180 is minus 1. This is the expression. समझ आ गया? Next 0 0 0 0, इसको लेना है, प्लस अल्फा, पहले इसको बोल दीजिए मेरे को, ds cos 0 अल्फा, उसके बाद 2a to the power half, not plus, multiply, integration of ds for surface number 3, ये भी कितना, a into a, that is a square. 2a square नहीं, a square, क्योंकि एरिया तो a into a है. ये हो गया, फिर से अल्फा अल्फा, 2a हाफ कांस्टेंट, 2a हाफ, ds का इंटीग्रेशन a स्क्वायर, हो गया cos 0 plus 1, cos 0 is plus 1, plus 1, it is done. And these are the two expression, and rest is what, 0. ये इसका मेन स्टेप था. Okay, it's all done. Now let us solve this one. इन दोनों में कॉमन क्या है? Okay, we'll write it again. What we are calculating, electric flux total is equal to alpha. पहले पॉजिटिव को लिख लेते हैं, 2 to the power half into a to the power half. We can write that. And this is a to the power 2. कितना हो गया a की पावर? Yes, 2 to the power half, root 2. Then a to the power 5/2. देखिए, ये a की पावर कितनी है, हाफ, और ये a की पावर 2. टोटल कितना हुआ, 2.5, 5/2. This is plus. Now minus alpha a to the power 5/2. ठीक है? Okay. Now you can calculate it very well. क्या कॉमन निकला? अल्फा a to the power, alpha a to the power 5/2. ठीक है, आ गया. Now it has become simplest. Now put the values. अब यहाँ पर वैल्यूज को पुट करिए और कैलकुलेट कर लीजिए. calculation. हो जाएगी. 0.1 to the power 5 का स्क्वायर रूट निकालना आता है. ओके, इट इज डिफिकल्ट, मैथमेटिक्स है, करके देखिए, यू विल गेट इट. ओके, सो दिस इज हाउ इट इज टू बी डन. पर फिजिक्स के प्रिंसिपल आपको सब समझ में आए कि हमने ए की वैल्यू कहाँ कहाँ रखी और इलेक्ट्रिक फील्ड कैसा चेंज हो रहा है. क्लोज सरफेस के इंटीग्रेशन को हमने अलग अलग सरफेस में डिवाइड किया, हर सरफेस का अलग अलग एंगल निकाला और उसको प्लेस करके फिर इसको बनाया. ठीक है, इस कैलकुलेशन की ये वैल्यू लिखिए सो दैट वी विल. गॉस थ्योरम सेज दैट सोर्स ऑफ इलेक्ट्रिक फील्ड इज इलेक्ट्रिक चार्ज. इलेक्ट्रिक फ्लक्स is the effect of electric field on a surface. So Gauss theorem has given us a relation between electric charge and electric field and the surface. अच्छा, अभी तक हमने फ्लक्स की एक कैलकुलेशन की. हमारे अनुसार फ्लक्स का फॉर्मूला क्या होता है? क्लोज इंटीग्रल EDS for any closed surface. So we will write it. Therefore, in the given numerical, Gauss law को हमने लिखा Q, the charges within divided by epsilon naught, उसकी वैल्यू 8.85 into 10 to the power minus 12. This is equal to flux, और flux हम निकाल चुके हैं. ये देखिए flux की वैल्यू है 1.05. So we write here 1.05. Now we have to calculate the value of Q. It's simply a transpose. So Q is equal to 1.05 multiplied by 8.87. (10 to the power minus 12). And you can calculate it. We do this multiplication and your answer will come to 9.25 into 10 to the power. Okay. So this is value of Q, what we get here. So this is how we'll find. This is the charge within the surface and closed by the surface, and it does not calculate outside charge. It is having a charge in it. Okay, please read this question carefully. An electric field is uniform. It is positive with plus x and it is negative with minus value of x. It is given that E is so much for x more than 0 and E is minus 200 for x less than 0. Less than 0 means in negative direction. More than 0 means in positive direction. Now a right circular cylinder is placed which has got length 20 centimeter and radius 5 centimeter. This is placed along the x line. Its center at the origin and axis is along x-axis. One face at 10 centimeter, other face at minus 10 centimeter. What is the net outward flux through each flat face? What is the flux through sides of cylinder? Okay. First, let's make the diagram. This is x-axis and this is our origin, 0, 0. This side is negative value of x and this side is positive value of x. They say electric field is uniform, it is positive in x direction of plus x. This is direction of plus x, so here electric field is in positive direction. With x less than 0, in negative direction of x, electric field is also negative. That means electric field is in this direction. This is negative direction, that is positive direction. So this is plus and this is minus. How do we come to know about it? Is positive in positive direction and in negative x direction, this has negative value. Okay, so positive in plus value, negative in negative. What is the value of E that is given to us? E is equal to 200. There is a cylinder. E is 200 on this side along unit vector I. I means in the x direction and here again 200 negative direction. So this is 200 in negative direction. Okay. There is a cylinder. A right circular cylinder is placed along the x-axis with center here. So we place a cylinder over here. This is the cylinder. This distance is 10 centimeter and this is minus 10 centimeter. 10 centimeter this face, 10 centimeter this face. And the radius is 5 centimeter, this radius. This radius is 5 centimeter. It is given to us. Okay. These are the situations. X is equal to plus 10 and other face at minus 10. The radius 5 centimeter. Center at the origin. Let us say this is the origin. 10 centimeter here, 10 centimeter here. This is 5 radius. So this face is like this with radius equal to 5. Okay, the first thing, what is the net outward flux through each flat face? The direction of E is given to us and it is also given what is the nature of electric field? Uniform. This is uniform electric field in positive x direction. This is uniform electric field in positive x direction. Now, how much is the flux with this face? So, flux with flat face. What is the formula? E into A into cos theta. This is equal to E into A into cos theta. So flux from face 1 is equal to, what is the value of E? E value is given to us, it is 200 Newton. 200 Newton per coulomb. 200 into area. Area is also given to us. Radius is given 5 centimeter. So area is 3.14 into R square. How much is R? 5 into 10 to the power minus 2 square. This is E into A. Now cos theta. Here, where is the area vector? Answer, this is surface area like this. So this is area vector. This is area vector. And this is E. What is the angle between them? 0 degree. So this will be cos 0. And cos 0 is equal to 1, which will not make any change into it. So this is the flux. What is the direction of this flux? Answer, direction of flux is outward from the face. So our first question is, what is the net outward flux through each flat face? Each. एक का निकालना है. So we have calculated it, and if you multiply this is 25, 25 3s are, yes, 5 5s are 25, 25 2s are this, and multiply with 3.14, and it comes to be 1.57. Yes. Newton per Coulomb. Yeah, you can make it, yes. 5 5s are 25, 3s are 75, 75 2s are 150. Yes, cancellation karke, this will come to 1.57. So this is the flux going out from this. Now see here, the direction of electric field is in this direction, and the direction of area vector is in this direction, outward. So area vector is always to be taken from a closed surface. In which direction? Answer, outward direction. This is the surface, this is outward direction. This is area vector for this, but for this is area vector going out. Okay, so the angle between the two is again 0. How much will be the outward flux? Outward flux from phase 2 is, all the quantities are similar, so that will also be 1.57. Flux, does it have any sign? Don't get confused with the sign. If you say this is minus E, then I will say this is minus A. And minus A, that was plus A. So minus A into minus E is again E into A. E into A. So what we are concerned is not with plus minus, inward and outward. Here it is outward, here again it is outward. So what is the total outward? What we have found? What is flux through? Okay, this is each flat, this flat surface 1, 1.57 outward. 1.57 outward. No, this is not B. This is part of A. Now we come to question number B. What is the flux through sides of the cylinder? Side, this side. This is electric field. If we take a small area of this side, then this is the area vector. Area vector for side. Now if we apply this formula, this is area vector for the side, and this angle is 90 degrees. So the flux from side is equal to E into A into cos 90, and this is going to be 0. So remember, we have discussed earlier, when electric field is along the surface that is perpendicular to area vector, then flux will be 0. This is B. Now, C. What is the net outward flux through cylinder? You have seen this is outward, and this outward is 0. So we have to make sum of these two.